Welcome to a new test and teardown video. This time it's a B&O, Bang and Olufsen AC Voltmeter RV9A. It is in a little bit of a sad condition, and that is mainly due to storage in high humidity, I think so. This meter is from about 1980, so it is of course also quite old. It should be able to handle from 10 Hz to 10 megahertz. We got 12 ranges, either auto or manual range. We've got some up and down switches here to change the ranges. And this is the power off. The ranges handles from -80 to +50 dB. So it's of course a huge range. It exists in a little bit a few different models with a data in-out interface as well. This one is not with this option. Got different low pass filters like that. So it can be 10, 1 or 0.1 megahertz. Grounding can be either floating or chassis, and that is the input supply fuse. As you can see here, it is badly corroded. And here, I think this reveals it was maybe standing on a wet floor. I mean, why is it more corroded at the front and also, yeah, and of course the sides, they're nice and, nice, but of course the top is also real bad. So maybe the rain is coming here, I don't know. This is probably a service sticker. I think the idea is you can remove this bottom plate and get access to some service. I was able to pull away the little bottom lid here, so I don't understand exactly what kind of service you expect to be able to do here, but I think this is maybe a case design they're using in many other instruments as well. See the corrosion here, and let's see if we can try and clean this a little bit. I don't know. This circuit board looks really weird with this white color here. What kind of corrosion is that really? But I'll try and open it a little bit more. I was able to find a full manual, the schematics, the whole nice things at peel.dk. In that manual you can find full specifications that explains all about the frequency ranges and accuracy and all that fancy things. There's also a block diagram and real schematics about every little circuit board and every little detail. So that should help me a lot if this one just blows up. Let's see what happens. Got a few really cool mechanical details here in this design. So here is mains entry. And here's the floating or chassis grounding. See? So there's a capacitor that is either shorted or the grounding. Mains switch is extra protected, so you don't get a little electrical shock here. And then it goes to the transformer. Manual also say exactly how to connect those wires for the different voltage ranges. So all that is fine. Output from the transformer goes down here. Let's see if I can get a little bit more light in there. You can probably see all the nasty leakage from all the 3 capacitors down there. They completely leaked and puked all over the circuit boards. So that is probably one of the reasons it is this badly corroded, because of all the acids in here. So all the white stuff you see here, look at all that. Is that acid puke from the capacitors or whatever happened? I don't know. This unit is in a really, really sad condition due to neglect, I guess, and maybe also wrong storage. Here we got the digital section, all the different ranges, auto ranges, and all that, handling of all that kind of stuff. Maybe this is the external remote control, because I think the same circuits, they will be here for handling the auto ranges and all that kind of stuff. So it's probably just a little cable you need, and then you have this upgraded version. Got some indicators in here. No, what is actually going on right there. I don't know exactly what is going on. I kind of like the way this. Yeah, look at that. So, so this switch is just springy hold. So when this goes out, pling. Now the unit is turned on, and because there is no mechanical grip here, because the chassis is away, then the unit goes in on. I can try and click it into off, but that is not going to work unless I push the cabinet like that. But so I go to on. Okay, cool. At least I know all that. So we got to unscrew the 2 circuit boards with this one, and then I can pull these out of their sockets, and then I'll try and do a little bit of maintenance on the 2 capacitors. So hopefully we can get this one up and running. So with the 2 circuit boards out, we can much easier see what is going on with, oh, it's really bad corroded all over the place, also between the rectifiers and all that. So there is a little bit of cleaning to do here. What I always do is take a few photos to see here, minus plus, minus plus, minus plus. I mean, this is very important because I tend to, you know, when I remove all these and, oh, how about this and that, but it's most likely also written on the circuit board. But at least I have a few photos to help me here. So now the capacitors, they're out, and I can see a little bit more about the damage. It's not super good, but it's not the worst I've seen either, so I think we can do that. I want to take this rectifier out and clean it up. And there's another capacitor here, but look at this black cable here in the middle. I don't know if you can see those drops. It looks like it's wet, but it's kind of, if I touch this, see? Goes away, and then I get some stinky snot on my. Ooh, what is that? Weirdo smelly. So all this is some. Is this still? No, it's not. It's not wet anymore or anything, but on the cable here it's still wet. How is that possible? I need to clean all this. And this is why it's important to clean up carefully and remove all the parts that hide all the nastiness. Maybe you know this, I'm putting in new components here, but I want to show you something. You know these rectifiers here, right? You know how annoying it is to stick these in, because the pins, they always do like this and they will never fit in and always drive you nuts. Here is a little trick. If you cut them different length, I mean, you can do it as much as you want. The more you do it, the easier it gets. So the longest, I prefer to have this one, the positive. This is also how it is original. But now, let me see if I can do this without having the fingers in the way. Now you can imagine you only have to fight with one little pin at a time, in this one, and in that one, and in the last one. And super easy, but I'm of course in the way of my own eyes, so I can't see what I'm doing. But trust me, this is how it's done, the easy way. Okay, let's look a little bit on the circuit boards. So this is the analog amplifier circuit board. I need to clean it a little bit, but this white coating, that is how it is supposed to look. But it changes, of course, color when it's maybe this is some old solder cleaning or some, I don't know exactly how this happened. Yeah, you can see everywhere we got those solder points. We got all this splat all over the place, and this changes the colors of everything. It's quite a nice layout, and this is of course the analog circuit board, and will be the field effect transistors and the attenuator resistors and all that kind of stuff. A little relay and frequency compensation. Remember, this thing works from 10 Hertz to 10 megahertz, so that is yeah, quite impressive. I don't see any leak around the capacitors on this circuit board. All the tantalum capacitors here, they are nice and shiny, so I just leave them as they are. As long as you don't give them a lot of ripple current, or as long as they're not connected to power supplies or voltage through switches or any kind of peak currents, I mean, they're really not that bad as their reputation have given them. But that's because people use them wrong, mainly. So yeah, like you see here at local supplies for decoupling, they're fine because they're on the outside, on the output side of regulators, where the peak currents, they will be very low and within limits. See the date code here? 76 for that one. So it's probably a few years older than 1980. I had an idea it would be 1980 because of this is when this unit was in some of the more known magazines. And here's the digital board, and again 76 and 77 here. So that will be the newest is from 77. So I think that will date my unit here. I kind of like that. Look at the numbers in the silk screen. That gives you a very fast overview of the pin out. So if you're measuring and, oh, I need to find pin this and that of this and this IC, look how nice that is. I mean, you don't see this very often with the numbers around all the ICs like you see here. It's quite a big circuit boards for all this, but they don't need this to be small and compact and annoying. It's a single layer design with quite a lot of bridges, and they're neatly marked in the silk screen. And again, the white areas, that will be the original coding. So this is how it's supposed to be. And all the changed color areas, I think that is because of all this soldering, and they try to clean this and they just let this dry. I mean, there's really nothing wrong with this. This is just a normal behavior of the way that they cleaned this board, and then they extra carefully cleaned it here. You see, there's a nice line of where they cleaned this, and then they just let this with all the flux and dirty stuff. Dry in the sun, I guess. So yeah, let's try and assemble this and see if it still runs. I also want to show the range indicator. So in these little white rooms, we got individual bulbs. That is so beautifully made. And in here in the meter, we got two tiny little bulbs, and they shine light through two tiny little holes right here to show you what kind of readout scale you're using, this one or that one. And it's of course because this whole unit is, we got all the automatic ranges indicated here, or you can up down the ranges, and of course those little bulbs, they indicate where to read out. Isn't that just beautiful? So this will be my first power up. I leave this in auto mode, and it goes flippity flippity blinkety, and it is in 30 volt range. I did not okay, that is better. Why are you? Hey, hello, is it me or is there a microphone somewhere? Okay, it definitely needs a little bit of well, how about I give this a signal like that? So okay, I am in peak mode. That is, of course, this is an RMS meter, so I should just give it a 1 volt RMS. And how is that working? So 1 volt is this scale here, and 1 volt is that one, right? So it's very, very, very close to that. I mean, that is impressive. Taking the conditions of this instrument. So if this is 1 volt, how about I give it, so it's going to flip to the next range. So if I give it 2 volt, it's going to, yes, and it's doing that all perfectly fine. So 2, and then 3, it can do the same range, yes. And then how about 4? And it's going to go to the next range. I mean, I totally love the way that it's changing ranges and all this. Absolutely fantastic. I'm going to go and play with this for a long time now. So that's 1 volt. How about we go down and see when will it flip down to the next range? 500. And then the next range, let's see. Why don't you? Oops. That worked. And then if I go up again, why don't I go up? Oh my, okay, here we go, 6, 7, 8. Okay, so, hello. There's some snot in the, now I got 1 volt RMS again. Hello, yoo-hoo. Okay. We got some loose connections here. Okay, let's try and repeat this. We go down, down. Okay, here we go, nice and smooth. Oh, look at that. 5, 4, 3, and then it flipped. Then it's not responding. So, okay, so there is, well. Why are you doing this? Where is that? Really, really weird. I was really hoping for this instrument to work perfectly fine. All the way. What if I turn this input off? So now it's just stuck in that range for whatever reason. So of course we got some range detection issues. And it's not those connectors. It's not a mechanical. But when you poke around here, you can get it to change ranges like that, right? But I can't get it. Of course, it's because it's open. So all this noise is background noise going into all its circuits. Oh, of course, that is how it is. This explains everything. And it's, of course, I don't have the bottom. I don't have anything on it. So Of course, that is why all these things, the scope here is running off a floating supply, and everything here just radiates in respect to, yeah, see, here you go. When you touch this, that is exactly what is going on with this. See, it can detect near fields of whatnot. All right, so I believe it still works. So I think that is all I wanted to show you about this instrument for now. I will probably put a link in the description to the full manual with schematics and all that kind of stuff. Otherwise, you can always go to peel.dk and find out any more super duper details. So thank you very much for watching. I hope to see you soon again. Bye bye.